My name is Chen. I come from a company, a Finnish company named ePassi. I originally come from China, but I work in Finland. That's my background. I'm a software engineer. Have about 6 years experiences in mobile development, and previously I was working in a consulting company for different projects, including front-end, back-end, things like that. Okay, today I will tell the story about our app. We are a fast-growing company that we have. Back then, we have very old legacy application, and this story is about how our mobile team managed to improve that by using relatively modern technology in mobile, in Android and iOS. But we are not following the. I mean, our code base is not strictly following the latest trend of the technology, but still you will see the change. So this is the agenda. First, I will give an introduction about our app and what the app is doing. Then I will talk about dependency injection, how we use that to involve the app. Then I will talk about the new architecture design in the app. Finally, we will have the question and answer session. And in the middle, I might ask you some questions. Don't worry. So, what's ePassi app? It's so our app is providing a service to users to make payment, but it's not currently. It's not about general payment, but it's about employee benefits payment. For example, benefits like lunch, sports, culture, commuting. And there are two roles in our user group. There are consumers, like employees, and merchants. Merchants can use also our app to charge the user or the consumer by either scanning QR code or manually charge through the app by some button click. Yeah, by the way, I would like to ask you how many of you are Android developer and how many are iOS? Cool, we have very evenly distributed audiences there. So on the left-hand side is the old Android project, and right-hand side is the iOS. As you can see, it's a monolithic, big project with everything in one module, and the logic is like grouped to separate packages. This is actually fine for applications that is small, doesn't need much concern about the long run. Especially for startups, it's a fine thing, I would say. But there are problems for companies like us, that we are growing fast, that we have more business requirements, more features needed, and a growing number of users. In that sense, that then the project we made previously, I showed you that we made was not smooth to extend and not easy to maintain, because we made things quickly, and the test coverage is almost zero, and we don't have nice UI UX because it's designed completely by developers. By the way, don't get me wrong, I'm not complaining, like blaming the developer who made that, but it's quite understandable. For many startups, this is a common issue, because startups need to release a product to the market quickly to test whether the product make money, and this is quite common issues. So, as our business grows, our user number grows. We have more and more demanding users which are not happy with our, for example, user interface or features. We have to design it, redesign it, and to make it more scalable. So we decided to redo the app. But before that, when we kick off this project, I mean the new application projects, we have this kind of background. We have 2 developers at the beginning, and we don't have sufficient UI UX still, but we have something. There's no knowledge transfer from next developer because he left for another project. And what he left to us is an untestable code base, and we feel the time spent on that code base probably, I mean, to refactor the whole thing, probably the same amount of time we would spend to start a new project. So we just redo the whole thing, and we try to have our mindset not influenced by the old code base logic so that we can completely rethink everything. But from the business side, since we are planning for the future and there are some business requirements not very clear to us, to the two developers there, but the business needs is there that we need this new app to be out as soon as possible because there are many users waiting. With that being said, these are the questions we asked ourselves before we start the project. So how could we make it more maintainable, testable, and scalable? And second, how many users are there waiting for this app? To be honest, I don't know the answer now still, because the number of users are still growing, and I'm not sure how many in total now. And we will have data analytics and data collections, because this is very common in nowadays modern mobile application services. The companies are very interested in user behavior on the app. Then we don't want to further burden our server. We have another issue in our backend back then, and we try to not increasing the issue in backend team. So those are the questions we asked ourselves in the beginning. So this is the old app. If you were us, how would you do? What would be the first step, or what would be the things in your mind from top of your head? Someone? Think it's a monolithic project, and now we want to scale it up. Yeah, that's a great answer. Exactly, we want to decouple it. So we want to separate the responsibilities. The UI responsibilities belongs to UI module, and the non-UI responsibilities belongs to the non-UI module. We use the term app module for the UI things and the core module for the core business logics. That's the very first general idea in our mind. And in the app module, by the way, this is very Android specific, but it applies to also iOS platform. So if I use Android as a reference for the app module, it includes the very front-end objects like activities fragment, and the presentation layer logics like the view adapters. And the app, in our app, we also use Google Map. There are some logics needed there to draw the markers on the map, and to draw the clusters, the number of clusters. Things like that belongs to the app module. That's the UI module. That's very UI related things. And for the core module, it's non-UI related things. We want to strictly separate them. So the core module includes all the data models and the payment rules. I use that little star or little asterisk symbol there to highlight that that's the most complicated logic in our mobile app at the moment. Then we have the networking things and some utility classes. We have also managed to create our own concurrency and queuing mechanisms by actually we developed something that is in iOS concept, and we implemented the iOS concept in Android project. That's a very interesting thing. Then we have this location thing, because we have a map. We need to show proper data on the map and handle the zoom in, zoom out thing. So that's about the core module. This is the overview of the new projects, iOS, Android. As you can see, here we have the app module, and here we have the core module. So they are separated two modules. In iOS, it's the same thing. There are two parts. It's like two projects actually. But in iOS, it's like a framework. One is like a library, or framework is like a dependent framework for the other one. So what comes to your mind if you want to have a more testable code? Yeah, sure. Good answer. Anyone else? Yeah, there could be multiple things come to mind, but there must be one thing: this dependency injection. So if you know the Spring framework in backend side, we all know that there's an important concept of dependency injection. So does the mobile platform. But what dependency injection you would use for Android? Do you have any suggestions? Mm-hmm. Mm. Sure. Yeah, I agree with you. But unfortunately, we are using Dagger back then because Dagger was very popular back then. I have to agree with you that Dagger sucks. It really sucks because it's not straightforward to use. Our team has had multiple confusions when using Dagger, but still, I want to clear something out in this presentation about Dagger. If I'm wrong, please point me out. So, since we have two modules, we need to have two kind of containers to host all the objects. The UI objects belongs to the app module, should be hosted by a separated container than the core module. With that in mind, we decided to have this app component. Component is a terminology or concept in Dagger world. It's kind of container. Just think about that. In this like container contains all the dependencies. And in the core module, we decided to have another container. We call it core component. Then in Dagger, there is another quite interesting topic about scoping. Since we have components defined, scoping is another thing that many people confused by the definition, because what is scoping? That's a question. There's many people get confused by this annotation, this at singleton. This is provided by Dagger by default. It's predefined. Does it really provide you the singleton? It does, in a sense, but there is a huge issue there. All the objects annotated by that would have the same lifetime as the whole app lifetime, which means all the objects are in the memory. But it's not necessarily needed to be like that, because for a mobile device, if you think user swipe the screen, the objects should be erased from my memory. But with that, it just keep everything in the memory the whole time. That's not something we want. And another thing about Dagger is this rule. We have to respect this rule. A scoped component can't have the same scope on the dependent component. Otherwise, it causes issues. So since we have two components, the app and the core, and there's dependencies of them, I will explain that later. So we can't use that singleton annotation from Dagger. We have to define our own. So that's not our choice. That's a no answer to us. So back to here, we have two components defined, and we need to have our scope. So in the app module, we have our app scope. In the core module, we have our core scope. They are customized scope, not provided by Dagger, but that singleton scope is quite nothing special, just one Java scope interface, Java annotation interface. But I will show in practice how it looks like. Okay, we have scope defined, component defined. We need to define the modules. If you know Dagger, there are modules. So we need to further group our objects to different modules based on their functionality. For example, in the core module, core project module, inside this core component, we need to have networking related objects. Then we have this network module. And for location things, we have the location module. Each module contains those provider methods to provide dependencies. And we have some custom qualifiers, down there, and some custom scopes which I already mentioned, the app scope and the core scope. That's the core part. And for the app part, is similar idea that we have also our modules defined in the app component. But hey, what's that injector component? That's very interesting, because we can't, for some scenarios, we have to define another component. But I will come to that point later. Just keep in mind that in the app module we have two components now. Okay, still I want to talk about something about scoping. That if you are confused by scoping concept in Dagger, scoping, to my understanding, it basically means the definition of lifetime of your objects. So for the app scope, it can, in our project, it means the lifetime for the UI objects. And UI objects is supposed to be relatively shorter lifetime than the core module, because core module is like non-UI things and serve the app for a longer time than UI components. And down here is the singleton provided by Dagger. And this is the lifetime scale. And the app scope has kind of dependency on the core scope. And this is our UI module. This is our core module. Does that make sense to you? I hope. Okay, how we did that in practice. So this is up there. This is our scope definition. It's just one Java annotation interface. We call it EP core scope. The EP represents our company name, ePassi. So we use the prefix EP core scope, and we use it in, okay, this one is the inside the module. Inside module, we have several provider functions. We want to scope the objects provided by that function, so we annotate that with the same scope. But if we only have this, the scope has no meaning at all to the app. We have to also use the same scope for the component. Only then it makes sense. Okay, then still, this is the core component. As you can see, the name interface EP core component. We explicitly declared those interface like abstract method, return some specific types of objects. The purpose of doing that is to have those type of objects exposed to the app module, like to the upper layer, so that the app module can inject those things. And another question to you: what would you do with a Dagger when you have a like API level restricted or feature specific objects? Okay, for that we use the subcomponent, which is another concept in Dagger. So with subcomponent, we can define something that is very feature specific, that the objects is only for that feature, not for the whole application. So this is our subcomponent definition. It's an interface with a, if you're an Android developer, probably you understand what name means. It's KitKat equal greater injector component. One of my team members defined that. It means some objects, especially for the Android 4.4 and above, but not for the lower version of Android operating system. But our app is supporting users' device from Android 4.1, so there is a gap. So we use the subcomponent, but how do we fill the gap without crashing the app? That's something I will say later. Okay, this is another concept in Dagger, Qualifier. Anyone know what Qualifier means in Dagger? It basically means that with Qualifier, we can specify different instances for the same object type. For example, here, we have two functions return the same type. It's OK HTTP client. Both of them return that type, but there is a special scenario in our project that we have the QR scanning feature in the merchant app, and that feature needs our app to forward the communication to third-party server, but we have no idea when the third-party server would give us response. So we have to have some timeout for better user experiences. For that reason, we have to define a specific HTTP client for that. So as you can see here, there we have the lower function provides a client HTTP client with timeout, but the other one without, because for all the other requests we don't need timeout for now. Yep. So this annotation is the Qualifier annotation. It's also our custom annotation defined in the project. Okay, then in practice, how do we define the dependency of components? We have talked about app component, core component, and one sub-component. Here, if you see up there, is the no problem. The app component. This is the interface of this file. Then up there, which I use the pink color box to highlight the dependencies. It depends on the core component. And here we define the announce this sub-component. And with these announcements or declaration, Dagger knows how to draw the dependency graph for the project during the compile time. Then, at runtime, we need to build components to create instances for injection purpose. How do we do that? Here, we pass the parent component as an argument to the app component. And here, we initiate the sub-component. But as you can see, we use some if-else conditions because this is only for Android 4.4 and above. So we check that API level and instantiate that at that point. But that's not good because that doesn't look very pretty. So we have to improve that as well. We haven't yet done it. Currently, this is our code. So, but it can be improved further, like this way. So we announce our subcomponent inside the module annotation. Why is better? Because Dagger is smart enough to detect automatically what are the objects needed. It's like only initiate this subcomponent on demand at runtime. So it's like an alternative way doing the same if-else condition thing. And this is the whole picture of Dagger elements in our project, like bird's eye view. And we have two modules. Okay, that's about dependency injection. Next is the clean architecture. So what pattern do you use in your project, like MVC, MVP, MVVM, MVM? Yeah, MVVM is very popular nowadays. But unfortunately, in the first phase of our project, since we have unclear business requirements, we still use the MVC because we have some pressure that we have to release the thing out. And as the business requirements getting more and more clear, and we are keeping updating the code and adding more features, issue comes to us. The controller is bloating. There are many logics there. The view and the controller are tightly coupled. It makes the code untestable again. We don't want to end up with like the old project that we don't have testable code. So we have to address this issue. Then this is the thing come to rescue us: MVVM and Kotlin coroutines. In the MVVM in practice, I think most of you already know that we define the view layer, the ViewModel layer, and one repository layer like a data provider. For the upper layers, upper two layers, they have no idea where the data comes from. It could come from networking or from cache. Then, if view asks for data, in the very beginning when the view is initiated, we have to show some data, then it asks the data. ViewModel would query the repository. Then the repository will have some logic to check the data where it could find the data, either from networking or from the cache. And we use retrofit, as most of you might or also use that. Then the repository wraps the response to another object. We call it resource. I will come to that point later. And it returns the data. Actually, it returns the resource back to the ViewModel. And the ViewModel uses the live data to wrap the resource, then serve the live data as an observable for view. It can notify the data updates to the view layer, and the view just need to register an observer on the live data. Yeah, two modules. In practice, this is the resource. The resource mentioned on this slide is this one. So we don't want to directly pass the data from response all the way up to the view. We want to wrap it. So we use this generic class. Because we want to tell the view the state of the data. Not only the data, but the state of the data. Anyone know what's this companion object? From where it makes sense to you? Yeah, exactly. So it's a Kotlin provided feature that's like Java static class, so that we can call those functions inside statically without create an instance and call the function through the instance. No. This is the happy path. When we get successful data, we wrap it in the resource and return it to the upper layer. By the way, am I too quick, or do you follow? I hope you follow. And this is an example in the history fragment. How do we use the resource? So we will check the state of the data. If it's loading state, we show progress indicator. If it's successful, we present it to the user. If it's error, we handle the error. Okay, this is the ViewModel. Sorry, I think I need to be fast. I take this screen as an example. This is a transaction of from user, and we use the term passport to represent the transaction for a legacy reason. Don't ask me why, because I don't know why. It's a weird name. So here in the ViewModel, we use the mutable live data to wrap the resource, and then in turn it wraps the list of passport. But do you see a problem with this? This is in the ViewModel. We use mutable live data passed to the upper layer. Actually, we had a mistake here. This this mutable live data is not supposed to be used. It should be live data because we are not expecting the UI layer to modify the data at all. So this is one mistake made by our team. We will change that. Then here we use repository layer to get the data, but there's no callback. Right there, it could be network asynchronous network requesting responding thing, but why no callback? Anyone knows? Okay. What about the launch? Does that sound familiar to you? Great. Yes, we're using coroutines here. So we have this base class also interesting. This is called coroutine ViewModel. I will go to there later. On the view side, we just register an observer. That's it. And the repositories part here, we query the network interface and wraps the data to resource. And again, there is no callback. But notice there, the function has a prefix, not prefix, but another keyword called suspend, because that's coroutine. So with suspend function, there's no callback needed. And we return that. I will skip this one. This is very simple. Just wrap the thing, wrap the response data to resource and return to the upper layer. Okay, back to coroutines. That's interesting. In coroutines, we have this is our base class of ViewModel. We have this job. A job is representing one coroutine. Then we implement the interface, this coroutine scope interface. That's provided by coroutines. We have to override one property, this coroutine context property. There we specify the job we use and the dispatcher, which is main. Main means the main thread, because we want the UI layer to always start work from UI thread and also observe, change, react to that on the UI thread. But the coroutines will handle all the rest of the multi-threading things for us. So we don't need to worry about blocking the main thread. Then when we cancel the job, the whole, everything started from this coroutine will be canceled, will be terminated. That's a nice thing. Imagine if user swipe the screen, the view get destroyed, the view model through the callback, we can call the view model to stop everything observing data, then just stop everything through this job. This is from coroutine scope documentation source code from coroutines library. As you can see, the launch function is an extension function to the coroutine scope. That's why we can launch that in the view model. What about iOS? I will make it quickly. In iOS, we use reactive Swift for MVVM. And in a nutshell, it's very similar like in Android, but we create a signal pipe. The pipe has input, output. So we are dealing with a stream of signals and a stream of data there. And in the lower layer, we are using this signal producer. The difference is that the producer, we can manage to stop the stream, but with pipe, the stream is ongoing there, but we can only start or stop the observer, right? In practice, this is an iOS project. We have this signal producer. It has a closure, which has parameter or argument with observer type. Through that, we can send data. Sorry about the red square, because there is some sensitive data that we can't show on the presentation. It's not part of our code. It's not magical code. Okay, and in the ViewModel, so there we talked about the repository. Here, ViewModel. ViewModel just start. Actually, here it gets the reference of the signal producer. Then it starts the signal producer with the observer to observe data. It returns a so-called composite dispose instance, which we can use to stop this signal producer task, signal producer work. So What about from ViewModel to view? How do we pass data up? First, in the protocol, we define the property with this type, this signal type. Then the signal create a pipe. So like in the previous slide, there's a pipe created. This is the pipe. Then we need an output of the pipe to notify the observer in the view layer. Then this observer is for, this observer is for observing data from repository layer. Once it observes data, it uses the input of the pipe to notify the upper layer by sending the observed data. Okay. And in the view controller, which is the view layer, we just get a reference of the output of the pipe and start observing the data and update the UI accordingly. But there is a further improvement we could do. That's in the signal producer. Previously, in the previous slide, we don't use this lifetime object, the parameter at all. But we can use that to stop our signal producer more nicely, because it can check the status of the lifetime and send interruption events to immediately stop everything. With previous code, there could be some objects still sitting around the memory and after a certain amount of time get erased, but that's not good. Okay, future possibilities. With this design, the future possibilities, there are two scenarios. One is that with the existing app we are having, if we want to have more big features under the hood, for example, if we want to have data collection, we just create a new module without touching the app module that much and implement the logic there. And if we want to have a new application but share the same logic in the core module, we just ship the same core module to the new app, and the new app just need to implement a new UI. Then we need to I think we have to wrap the core module, expose some API to serve the new app. That's it.